No, welcome to the Hemp Build Podcast. This is January 2026, and we're here with Tim Callahan. And Tim, you want to get us a quick introduction of yourself, and then we can dig into a few more things and some technical issues as well today. I know you were instrumental in a lot of phases of the industry. This coming into code, that's what we're going to talk about. But first, we want to know who you are, and the way I describe it is tell us your backstory and how you first got into this, and then we can unpack some more of the details from along the way, because you've got some great projects to share, some experiences that would be relatable to the architects and the building professionals that are in this space. And so tell us about yourself, backstory, and then we'll jump in.
Okay, well, thanks, Ray. It's good to be here, and good to see you both. You too, Gene. I live in Asheville, North Carolina. I've been here about 30 years, and I won't give you my backstory because I'm 70 years old, and we don't have time for that. So, but I've been in pretty much the design build field my entire life, and across a number of different sort of venues. And I got into, in 2000, around 2007, my business partner and I, we decided we wanted to build the most energy efficient residence that we possibly could come up with. And that we started design development for that in 2008 and broke ground on that in 2009. That was a NauHouse prototype, which was a hempcrete residence, and arguably one of the first in the country. Our parameters for that really had to do with energy efficiency and healthy indoor air quality. It was a real community effort. It was amazing to see how all that came together. And, since then, I have been involved in quite a few hempcrete residences, varying in size from around 1,200 to 9,600 square feet, in a number of, all over the country. So that's the quick story.
So, what were some of the motivating factors that drew you in? You said we want to build the most energy efficient house. Tell us about your discovery of the material. Were you researching it? Did someone tell you about it? What was the discovery point?
Well, I've been, for probably around 1995, I really started getting into non-toxic, really looking at non-toxic materials and assemblies for residences, partly because I had been in the boat business previous to that, custom boat building, and had realized I had a real awakening as a result of some highly toxic environments there. And I just thought I did not want to be a part of efforts that were bringing, things into people's lives that could have long-term ill effects. So in 95, I really started pushing in that direction. When we started on the NauHouse prototype, that was really just with a conviction that we wanted to show that a net zero residence could be done. A healthy built net zero residence could be constructed, and a viable option. So in the core, and we had no intention of using hempcrete when we started that process. We were looking at a number of different methods and materials to go about achieving, our design goals. And my partner at the time, Clark Snell, came back in the office and said to me, Tim, I just came back from, this seminar about a material called hempcrete, and I think we should take a look at it. And my initial response was, oh no, we do not, we are going to go there, because we've already gone this far down this path, and now you're going to bring a whole new thing in. And I also I'm but skeptical by nature, and I like to see the but I love Clark. He's a great guy. I have a lot of respect for him. So I said, okay, well, let's get the data on this. And fortunately, the people that had presented this were a very reputable out of England at the time, because there was nothing available in the States. And we got the information, and I was really surprised because it ticked all the boxes that we, all of our concerns about air infiltration, its ability to insulate, but most importantly, just about air quality for humans, the human aspect. And I mean that there's the carbon sequestration, component, or the lower carbon footprint, relative to some other methods, was also, I mean, that was like a bonus. That was really a bonus. But that got us into our first project, after which, we just continued to build on that.
Yeah, I'm fond of saying it checks everybody's check boxes, and usually you come in and you discover the material through one of those check boxes, and then the rest of them are just as like, oh wow, it does that, does that, and so it does everything. And so you did it through wanting to be efficient, as well as healthy. And then I know the health and wellness is a huge, especially post COVID. Everybody was trapped in their house. They realized, oh, hey, this isn't that great for me. And there's some people have hypersensitivities. They're on a quest to discover something that has that health benefit. And so, for the design professionals that are listening to this podcast, we want them to know there's a number of different motivating factors for those potential clients to discover you and discover a niche that you would build out utilizing hempcrete as a building material and hemp altogether as a building material, because there's quite a few options that go hand in hand. And that discovery was in place. You realized, hey, this is going to be a challenge. There were no supply chains domestically back then. Tell us about unpacking some of those initial challenges once you got step 2 or 3 down that phase of ideas and putting all those together. So, and were you collaborating with the builder at this point as well?
Well, first we did. I don't remember when we brought a builder in. I mean, because but it was fairly in the process. But going back to your question, just about some of the, before I forget, your question about some of the methods or we had to address. I think one of the hardest things, and the things that we've made some real improvement on, had to do with installation, because our first, most of what I've been involved in has been a cast in place system. And for those people who don't know, that's essentially where you have forms, you build forms in the wall, and you the hempcrete into those forms, in about 2 foot, well, 8-inch times 3, 2-foot lifts. And the forms can be moved almost immediately, and sometimes, depending on the size of the house, that when that happens, it is different. But the project was extremely time consuming in terms of the labor that went into the process. So since then, we have evolved that to where we've reduced the labor by about 60% over the first and second projects. It's simply, I think that's pretty normal for any nascent sort of industry, or when you're starting out. There's just a lot to learn.
Yeah, and then that early collaboration is something that I strongly encourage, because, and even down to the subcontractor and the supplier, because job site logistics and from where you store equipment and materials makes a difference. And then how that gets delivered, and then that subcontractor, when they're turning a corner or going around conduit or making a wall to roof transition, all of those things really matter, and people can innocently make the lives of the other people difficult if the design is wrong or the staging of the completion is wrong. And so, were there any of those issues that you discovered beforehand, or any standouts that you're like, well, hey, I won't do it that way again? I know I've got some of those, the best to not do it. Were there any of those standout examples that people could come together, not only for the benefit of knowledge, but also the benefit of how was that collaboration executed?
Well, the collaboration, I think every project is a collaboration. It's a lot of people. It literally takes a village to build a house. It takes so many players with so many different skill sets. So, in a way, and that for any building, I think any that's going to be built to code. They are a complex interaction of systems, and it takes a lot of different people, that play their part. So I think. When you're doing it with Hempcrete, there is, pointed out, Ray, there are some additional considerations that come into play, and the supply chain is one of them. And finding people that have some of the skills, although it require a huge amount of skill, for the basic installation. But this is not something that you can just go out to Lowe's or Home Depot or your local building supply and get these products. So that's where, having a little where those materials are going to come from. Shipping costs can be considerable. So really proper planning is really important. So I think that going to the collaboration thing, it requires a little more planning, a little more good communications with your suppliers, and really mostly common sense. I think that there are different choices that get made. So there's almost always, even for experienced contractors or builders, there's going to be something of a learning curve if you're working with Hempcrete. But I always, it's just it has certain properties and that's why it can be very, valuable. And I think understanding what those unique properties are, it can just become another, color in your palette to work with, because it has amazing potential to address a lot of challenges that I have personally encountered as both a contractor and a designer.
And so you're going through the process, and then and you've done it on several different builds, and that's one of the things that we want to benefit from, especially on the focus of that collaboration and discovery of the design and the build team. And then and so we'll unpack that. Walk us through just a briefer of the first 1, 2, 3 projects. So you've discovered the idea, and then you did project 1. Tell us a little bit about project 1 versus project 2 and 3. How did those come to be? Was it similar? Did you do something and then now it's for the process?
Well, the first project was passive house energy standards, because we were looking for a metric, not that we wanted to necessarily, build a passive house, but we wanted an establishment that we could use as a yardstick for what we were doing. So in addition to that, it was very much had a lot of other natural building elements, like we made compressed earth blocks from this, site excavated clays that, we manufactured on site. We use that for thermal mass as part of the passive strategy for heating and cooling. We processed some of that clay also into finishes for the interior wall finishes. Some of our interior finishes were lime, some were clay. So it was the extent that we could do it at the time. It had a lot of natural build elements, and I always want to give a shout out to all the unnamed heroes out there, that made it possible, because it really was a community effort. It was that was not really viable commercially from a cost basis for most people. It was just high labor. So then the house, and I may get these mixed up a little bit. The second project was more of like, in some ways it was more like a normal house, but utilizing Hempcrete wall systems. So the client there had a very specific idea of what they wanted to achieve, and it was larger than NauHouse, but also I think more developed or more sort of mainstream, although still in kind of an old world style of architecture. It had, like the heating systems were just regular, common heatings, and nothing really outrageously innovative, except for the fact that it was hempcrete, and it was really it was a beautiful house. The contractor did an amazing job. The clients were beautiful people, still are, and we did to after the NauHouse, and when we looked at sort of some of the methods that we were using for placement and forming and just getting the hempcrete into the walls, we realized that, wow, we've got to do better than this. We were following the instructions from the folks that came over here from England, how they did it, but building things my whole life, and I think just like always look at how can we do this better. That's there's with every single project and every aspect of every project to really look at it and say, oh, I'm sure there's a way to improve this, and there generally is. So we did make some changes in our approach, installation on that one, not major. We also got a chance on that one to explore some different methods for providing basically lateral resistance in the walls for shear strength, because we designed it for about 130 mile an hour winds, whereas the NauHouse was 90. So there were some other structural considerations that came into play. Then the third project was, I think, when we really made a big leap in terms of installation methods. And I should also say that over the course of those first few projects, our ability to obtain materials got much easier. Partly just because they're a company that we both have with, and it got where we could just get on the phone and say, I need a container, and they'd say, okay, it'll be there in a month, and so this is obviously prior to anything being grown in the States. I'm talking about probably 2012, 10, I don't know, 11, 12, somewhere in there. But we did really, that third project, we made kind of a quantum leap in terms of our install, and because we started thinking about a number of things differently. One was where the lateral resistance was coming from, whether it was moment frames, concrete columns. I mean, right now I use about 7 different configurations, and knowing how to establish reference planes using structural elements and just things that speed up that process. So there's a whole sort of a slip form thing that we've developed that has worked out really well for cast in place. And that's a quick synopsis, Ray.
Yeah, I like joke with anybody who comes onto a job site. You will not leave without becoming an inventor, because there's so many different ways to do. There's so many different ways to design, and then that leads to a lot of design flexibility. But so just to keep it on a pathway moving forward, you've got projects that are getting under your belt. You're innovating each way along the way. And then you mentioned a lot of the unsung heroes of the natural building space that were instrumental in building code. I know the straw bale community
Right.
did a lot for the natural building and then code development that is alongside of what we take benefit of in the hempcrete space. Unpack a little bit of that innovative process and then how you became involved in the IRC code. Now, for those who aren't aware, there's the IRC Appendix BL that is part of the new IRC code that's in its wave of adoption right now. And so unpack how that process was initiated and how that site innovation from project to project transitioned into developing some of these code appendices.
Well, I think it's good that you bring up the straw bale code, because that really was there was a time in teens where we included parts of the straw bale code in for permitting. Mostly it had to do with finishes and some elements, but because we were struggling. There weren't any precedents on the ground here that we could point to easily. So we thought, well, this is something we can lean into. This stuff, the straw cell appendix, and that was actually really helpful in getting, helping us get certain aspects of the projects through. The it became really apparent to me after an attempt to get something built in the city of Atlanta, where they absolutely, without ICC approval, they were absolutely not even going to give us the time of day. And this is probably 2015, and I spent a fair amount of time on this project, and I just realized, okay, well, we need to raise a bunch of money so that we can really put together a team to develop, do some testing, and getting this into the code. That was not a policy wonk, and I had a business I was running at the time, but that's certainly when I thought, without that, every single building is going to be an uphill battle. So when I guess it was maybe 5 years later, and you might know, Gene, it was 21 or 22, there was a group that put together a proposal to the IRC, or the ICC, that was going to be meeting in Rochester. I guess that was 22. So it must have been.
Yeah.
Yeah, but it was in 21 the team got put together.
That's right. And hundreds of volunteer hours. And that's one of the exciting things, was that you were the one that did the drawings for the wall sections. And I have those here that we can share, and maybe we can walk through those. But an understanding of what were out there as far as wall assemblies, and then being able to put that and basically use your experience, but also some of the experience from folks in France and folks in the UK,
right,
and Canada, who had already done this before, and Ukraine also.
Oh yeah.
Who had already done this before, so for 30 years, and being able to take that, concentrate all of that experience into an actionable code.
Yeah, well, it certainly is. It's good that you brought up the folks across the Atlantic, because they really, they're been way ahead of us with this for a long time. From its origins, and including, I think just they've got a lot more data. They've been doing research on this much longer than we have. And that was what we really relied on. I had to, initially, I'd have to go and dig up studies and engineering, which technically, could not be accepted here because they weren't done by U.S. labs, but it's something to refer to.
All these people got together. There was some volunteering. There were then some consultants who had done the straw bale codes. And U.S. Hemp Building Association worked together to raise the money, and then also get the code written, and great collaboration. Can we share some of these drawings? I wanted to just go over the wall assemblies with you and just talk about the IRC, because this this podcast is aimed at design professionals and people who are making the decisions. So the question is, how, what choices do they have as far as code compliant, that they make that will be the easiest to permit and move forward with projects. May I share the screen, and we can go over these designs, and you can maybe give us an overview?
I think you're in control here.
While Gene's pulling that up, the main thing that we want everybody to know is that the work has been done. The cliche, "we are standing on the shoulders of giants," is completely accurate. There were so many people that came together in the collaboration to get these codes written and passed through, both here domestically as well as internationally. And then, so right now, it is available. a lot of folks were like, yeah, I've heard of it, but I didn't think anything was in code. It is in code. And then now we can unpack a few of those options and just to take a look at them. And then what was nice, Tim, is that we use that to build out some life-size samples and demonstration models here recently, and that were on display. And then we have those, and then we can add some of those pictures in of as-built demonstration models as you're describing this. And so we'll be able
Can
to
you
put
guys
those
see
up where
this?
people can see that.
Yeah, let's go over these 4 wall samples. Now, these were deliberately designed so that you could use cast in place blocks or spray systems to do these wall assemblies, or even, you know, create them as separate panels. And you these drawings. Can you tell us a little bit about them?
Might have done some of them, but I know I had to go through all of them and redo them at some point. I've done or whatever it was. Yeah. So you want you to go through this?
Yeah, just tell us, you know, we don't have to
Okay, well, first of all,
talk about every single little thing, but just, you know, the fact that there are 4 different wall assemblies that are approved in the code, tell us a little bit about that.
All right, so first,
and then
go ahead, Jean.
And then talk about each individual one here.
Okay. So before talking about this one, I would say, and I think this probably applies to all of them, these are generic, you know, the top of wall condition of the top plate and epsil are really, there's things to consider than it can be shown here. However, the basic configuration here is, this is an interior, well, first, this is an interior stud wall. So what that means is that this shown here is, you know, roughly probably, I think, about 9 inches of hempcrete with finishes on either side. And the structural wall is embedded within the hempcrete, set to the inside plane of the wall, which is easy to see by the location of the, you know, the top plate up there. So then the finishes can be applied directly over that on the interior, and then on the exterior, these are present that you'll see, or other finish per section BL 104. So that can be referenced for how you approach the interior and exterior things. So, but before we just go forward, so the things that are basically represented are this configuration. The studs are on the plane of the wall. There's one where they're at or near the middle of the wall, and another one where they're to the outside of the wall. So there are different reasons why you might want to do, you know, why you want to choose one over the other. You know, from an execution standpoint, in some ways, it's to be consistent throughout the whole building, but there may be reasons where you wanted to change it up a little bit in different places.
Like attaching cabinets, right?
Like cabinets, there's a significant, when you're doing it this way, when you've got the studs set to the interior and you're going to plaster over it, you have to use a basically you have to use mesh, like a slip skin and a mesh over the studs for the plaster to bridge it, which is, you know, it's additional work. So it's like everything, understanding, you know, what you do and why allows you to sort of make a, you know, benefit analysis of what approach you might want to use.
Other than your finishes and cabinetry and you know, potential cladding, what were some of the main why you would pick one over the other? And I know the last one that hasn't been mentioned is that you could have an actual double stud configuration. So you've got flush to the inside, flush to the outside, in the middle of the wall, and then a double stud. So those are the 4 scenarios. What are some of the considerations for the decision making between those?
Well, I think as Jean said, I mean, one of the considerations is, like, if if you have cabinets that you want to fasten to it, although you don't have to put the studs to the interior to do this. You can block it out if you want to, you know, from a center stud or even from an outside stud. But that would be one thing. Using the studs set to one side or the other if you're forming it from that standpoint, it simplifies because you've established a reference plane to do that. It's, in place, it's already there. One of the negative, I think one of the negative things about having the studs set to the inside and to the outside to some extent is fire. So we have, the highly resistant to high heat, and with it's got a smoke and flame spread index of 0. We have passed the E119 test, which has been accepted into the 2027 IRC for 1 hour rating, but we're going for a higher rating soon. So if they're in the middle, they're further protected. The structure is further protected from any fire damage. They're, from an energy standpoint, I'm partial to putting the studs within the wall, partly because of energy and longevity. They're protected. The lime acts as a preservative. I think, there are, if you want to move on maybe to the next one, Gene, we could take a look at that. Okay, so so obviously if you're going to screw heavy cabinets to this, you got to think about it. You could blocking to the inside of it, to hang the cabinets on, but that's just a consideration, which you may want, whether you just, that's worth it for what you're trying to do or not. This just shows, I think that's the only difference here really between this and the other one. Everything else is pretty much the same. So I've kind of covered it, but yeah, putting the studs on the inside are to protect them obviously from water, from degradation, from fire. So then the next.
This is to the outside.
Right. So the outside, the only reason I've done this, the only reason to set them for me to the outside is if you're not going to do a plaster finish. So, one of the considerations one of the primary considerations with Hempcrete is it needs to be able to breathe. It needs to be able to breathe to the inside and the outside. So if we plaster on the interior, that takes, that'll take care of the breathing there, and it also cuts down on air infiltration. You need to have a continuous skin on one side of the material. So here we've got on the interior. On the exterior, you could do plaster, but that means that then you have to do that whole treatment over the studs in order to bridge it to plaster it. So, which really, it's a lot of work. But if you put the studs to the outside, you can then put a membrane there and space out siding. You could put any kind of siding that you want. If you want an aesthetic that has, anything, clapboards, metal, whatever kind of siding you want on the exterior, you can do it. With it, that's putting the studs to the exterior. So those are some of the things that come into play.
Yeah, so we've got fire, we've got material selection for cladding on and finishes on the interior or the exterior, the configuration of your mechanical, electric, plumbing, and how that's going to be run, and then you've got options. That's the main thing that design professionals and these installers, when they're going to collaborate, is there's not just one way to do this. And then there are more ways to do it than are even in code. And so if your job
let's focus on
yeah, I know. What I was saying,
this
is just the tip of the iceberg, and then you can get overwhelmed a little bit. But the heavy lifting has been done, and you've got 4 very clear options that are out here. And so that's what we're wanting this podcast to bring to the market first, and then more innovation can happen. But just know that you've got 4 clear options, and then they're there for you. And then if you have a unique or a unique design preference, whether it's you need to reinforce for wind shear loads or seismic activity or anything like that, talk a little bit about the barrier, weather barrier, not a vapor barrier, and what some of those options are. You mentioned that you need to have that on at least one side, and that the plaster does that. So draw a little bit of those or unpack some of those, and then probably a good point to make the distinction between stucco, Portland stucco, and and old school lime plasters as well.
Okay. Well, first, I just want to go to something you said just before that, Ray, and that is about there are possibilities, and it reminds me, I remember when I was a kid, I think there was an ad that was put up by Ferrari Motor Company, and it was like, if it can be conceived, it can be created. And so, yeah, I'm not sure that's always true, but I do think it's really, to me, having an open mind and really being open to the possibility of where it might lead you rather than following a prescript. The code provides a great prescriptive framework for executing projects. There's a lot of information there. It gives you a lot of assistance and foundation for doing a build, but it's not all there is. It's what we do is really only limited by our imagination and money. But so, having said that, about the air barriers, so I've told this story many times, and that is when we did the NauHouse, the first project. It was really we had some students from Warren Wilson College, a local that helped out a lot, and they came over, and over the course of the project, they did 6 blower door tests. And we were looking at where, what was really happening at different stages of construction. So the first that we did, as the fan was running and sucking air, trying to pull air in through the house and the walls and the, wherever, you could hold, and this had 16-inch thick hempcrete walls. You could hold, and I did this, I held a match up to the interior of the wall with a fan on, and it was flickering like this because it was pulling all that air right through the wall. Now, by the time, and then we did it again when we had, when we had like plaster on one side, and at that point it was almost down to 0. We did at the end when we did it, we had our air 0.62 at 50 pascals, and which is not quite passive house, but almost. And so that those plasters really are what prevent air from just blowing right through the house. So the difference, and when I say skins, plaster, this is a lime plaster, which is very different than a Portland base, even though Portland is also made of lime. How they're processed and their chemical composition is different. So concrete is not really, Portland cement is not, when it cures, it's not really vapor permeable. It doesn't allow the movement of gaseous vapor in and out of the wall. So which in on a hempcrete wall, we want things to move in, and we also want to let them be able to come out. So that's where using a permeable plaster finish on the hempcrete is essential. And I think it's really worthy of note, because this was one of the big appeals, when we, our first project, is like, wow, we don't have to use mesh. I talked about using mesh to bridge like over studs, but if you're doing a center stud, or if you don't have to do that, the hempcrete itself is the mesh. So you can put directly on top of it. You do not use any sort of vapor barrier, like no Tyvek, or anything like that. That's basically not only not necessary, it's bad. It would be really bad practice, and it may be prohibited in the code. I don't remember. So so that is one of the air barriers, is that at least one of those on the interior or exterior has to be plaster. The other, and then how you might, on the let's say the exterior surface, if you're using, let's say, clabbered or something, you just want to have that look, and you spaced it out to allow it to breathe. Then there are some ways that you deal with that outside. There is a membrane that can be used kind of as a formwork. It's called Mento 1000. It's a high perm. It has a really high perm rating. for spray applications. It can be used like sort of as a backer to spray up against. So those, I think, are the primary considerations. But always thinking that this is a living. I just really think of it as it's kind of a living thing. It's breathing, and all are really. This is just a little more dynamic. The Hempcrete is a little more dynamic because of its properties and its ability to take on and release vapor, without getting waterlogged or moldy. So it's different in that respect.
Yeah, it'll absorb through the structure of the hemp, but the lime does not like being wet, and it's going to push that back out. And so it's got this release that takes place. And so we've our plaster, the lime plaster, not the cementatious stucco. And then on the interior, there's also really nice clay plaster finishes. Did you have any projects that utilized the clay?
Yeah, we did a number of not all the interior. You can't use clay on the exterior. I mean, I know natural build folks that do that. I personally am not comfortable with that. So, but on interior, I think that's great. And so yes, we have on the NauHouse. We did that on the NauHouse, and I've done it on another local project here. I think there's only two. Partly because we were on the basis of making it from us on site, and that's a work. I've actually thought, maybe getting from American Clay or just a clay supplier might be another way to go too, or to consider.
That's what other people have said.
Yeah.
And plus they have the colors. They have all kinds of pigments and other stuff so that you can get that right into the wall. Should we go on to the double stud? I think that's the next one here.
Sure.
Yeah.
Yeah.
This is, never actually built a double stud Hempcrete building or designed. Well, I've designed them. I did a whole series of things of designs. I called it the Alenia series, where we had a double stud wall, and it was the reason that we did that had to do with it was a more modular system, and it was for transport to do a double stud. So more like along lines of a panelized system. But again, here, if you to do this, I mean, this is another option you have. So if you decide that you need to have those studs, or you want to have studs on the interior for whatever reason, you can do that. You could. And on the outside, again, usually for the exterior, the only reason I can think of to do that, although I'm sure there are others, is if you're going to do a non-plaster siding to the exterior. So, I mean, I think this certainly is a place.
Yeah, and it definitely makes your formwork speedy and nice and easy there from the logistics on the installation. And so there's the thing to know at this point is that you do have options. You're limited by your creativity alone. As long as you know what some of those options are and the reasons why you would choose some of those, whether it's your finishes, your motivations, whether it's fire, whether it's a look or whatnot. You can make all those decisions as you go through, as your design is taking shape for those who are coming into this space. And then a handful of these options are spelled out actually in code, and then you can take on with your creativity along the way. So what are some of the other experiences that you've had that you'd like to share, or frequently asked questions that you see as these projects come to you, processing, and then go out to fulfillment? What are some frequently asked conversations that are had?
Well, I think one of the first things that comes to mind is, and again, this is like, how much is it going to cost? And I would also say that, as in any project, you really don't know until you have a really good set of drawings. And so that's always that, from my standpoint, that's always that sort of chicken or the egg thing. So, how you progress with this with those considerations on a hempcrete build is pretty similar, to how you with anything else in terms of the design process and how it gets structured with a client. And the other thing is, well, how do you deal with the fact that you can't use plywood in the exterior walls? This is something that initially gotten better. This is like a lot of things. Before, when nobody had heard of this, it was just well, how do you build without plywood? Even engineers, like, well, if we're not using plywood, I would be told that if we're not going to use plywood, how can I do this? So in terms of dealing with those lateral forces and shear walls, I think that's the other thing. It's really good to have a grip on, not all of which is spelled out in the code. So this is where, knowing that it doesn't mean if it's not in there that you can't do it. In the code, under the prescriptive, options listed in the code, we talk about lead-in bracing, and that's how, like, I live in a house that was built in the mid-60s. And I've been doing some work on it recently, and it has lead-in bracing, right? I mean, so, and I've done a lot of work on old houses where it's lead-in bracing, where it's set it in different angles like this into all the studs, and it makes big triangles, and it keeps things from shifting like that. So that is in the code, with some restrictions on the overall wall height and overall building height. However, there are if you're in a situation where that's difficult, or because you want a window there and you need some bracing and it's not, when there are you can use reinforced concrete columns for to get strength. You can use steel moment frames or brace frames, and I'm not even remembering all of them, but there are.
Yeah, we got the masonry columns right here on this picture. Can you guys see that? Yeah, tell us more about we have pictures of the concrete posts. We have pictures of the metal braces that you could use, because I think in your region and in South Carolina, you have wind issues, you have with hurricanes, you have seismic, and you have moisture mold issues.
Right.
So you really have a lot of things that these buildings and these wall assemblies need to address.
Yeah, and the seismic issues in the Carolinas are really only around Charleston. That's just a little, there's a little epicenter there for seismic activity, but the rest of the Carolinas are pretty good. But yeah, if you're on the coast, or we've got wind considerations, or like certain ridges above 3,000 feet, we follow wind design categories. So they're done. I had this large project that I did, when the client came and said he wanted a steel frame. I was like, yes, we can do this. So, it made just like really straightforward. So we basically, had these, the building, or the main part of the building, the core was just big moment frames, and we were able to build around that. That was, that gave us a lot of latitude. You can also put them, we had, that I mentioned earlier, where we had 130 mile an hour wind design, was those had steel frames that were embedded within the hempcrete walls. Now, when you do that, like with any metal, you've got to isolate, you've got to coat the steel so that it does not have contact with the lime, because it'll react. You'll get a reaction between the steel and the lime, which will degrade the steel, and that's not good. But that was another method to use.
Yeah, that brings up a few little points and tidbits of some of the building science, where you've got the migration of moisture that needs to be managed. You've got the alkalinity of the lime material. And the way I like to describe it is that if you're a designer or an engineer or a fulfillment side of the project, you have to relearn your whole career path. You have to learn a new material and how to modify that. I know you've got, Gene mentioned your book. That's a nice resource. What were some of the other processes that you underwent for that learning curve? There's networks, there's the community that's available for professionals to engage. What were some of those early on collaborations that were beneficial to you, professional to professional, where built out these skill sets?
Well, I think I'm really fortunate to have, to be working closely with a couple of people who were just extremely conscientious about getting solid data in. So, I mean, it's been, there are things to learn. And I feel like whatever it's now, 15 years or something, I'm really starting to understand like some of these things on a level, especially about lime, because to me, lime is, I mean, there's a real interesting relationship between the lime and the hemp herd. But the lime to me is sort of like the magic ingredient because it is dynamic. So I think it's talking to people, it's reading. I mean, I've got, as I said early on, there really was, it wasn't like I could just, you couldn't just go out to Lowe's and get something and then go build it because, once you got it, then we had to building a department that this was going to be okay. So that compelled us to do an enormous amount of research and just really learning things that, in most cases, or, most similar scenarios in the traditional so-called build, you'd never have to go out and learn. I would not have to go out and learn, how do they manufacture plywood? What are I mean, all of every little thing. So again, thanks to, mostly our European counterparts and studies that have been, that they had done over decades, that was really that we probably could not have gotten anything built.
Yeah, and there's of it all, and then there's the building science of it all. What were some of your points of discovery for the building science? I know one thing that just makes people's head explode is when you instruct them to not put a house wrap on there. So you need a weather barrier, an air barrier, and then not a vapor barrier. Tell us how people reacted to that. Tell us about your learning on all of that.
Well, it's definitely a lot. I mean, initially when we would have conversation, we had with all kinds of information about the, material properties and performance information in order to, we spent 3 months getting our first project through permitting. And that was working full time pretty much to satisfy their questions. And I mean, I have absolute respect for what they were, for those building inspectors, because the majority of inspectors that I've dealt with, it's new to them. They've got it to do, but if you could, which is really important, and if you can show them that this is going to, be safe for people, that's the main thing. Is it going to be safe for people, and is it going to stand for a long time? Then you, where was I going with that?
Oh, just some of the points of inflection for your learning discovery, really. A lot of people, it's like staring at a new gate when you say, no, leave the house wrap out of this. And they're like, what? That's one thing we have to do. And then, there's some very tuning of the building science that we incorporate from project to project. And some of it just makes people's head explode. And so I'm sure there's some stories along the way and the encounter of it all. And then again, back to the good resources for learning that.
Yeah, I think it's a lot easier, Ray. I mean, over the years, I find that in general, and maybe it's just because of who I run into, but it seems like just building science in general. It used to be that was just almost an esoteric thing not that long ago, where you talk about building science and vapor and eyes would glaze over builders even. But I think there's most people or most professionals, they if not well versed in it, they understand there's an understanding of the basic principles. So that's a whole nother thing that if you're starting from scratch. So but it's and building officials too. I think enough things, whether it's straw bale or hempcrete or whatever. I think there have been enough innovative things go on in the housing industry that although they're like a learning curve and it's good to budget some time for education of building officials, because I feel like that that helps everybody. If when projects, if we've done our homework and we can sort of enhance their knowledge base, it works in our own interests, and it works for everybody else's as well.
What are some of the key takeaways that you would like to a building official to have on this? You know, they've got to do. They're making sure that it's safe
Right.
for the population, and and really we're asking the Hempcrete to do two things. One is to be insulation, and two is to be a substrate for plaster. And then we're asking the plaster to be an air barrier, a weather barrier, but not a vapor barrier. And then if it's on the inside, it just needs to be an air barrier, not a weather. And so, what we ask the material to do is important for the understanding, one, that it's not structural. What are some of the other key components that you would like a building official to know? And there's some points of friction?
I think the points of friction, have in the past have often just been about for them to understand that it is non-structural. And then also, I think it's important for them to, now that we've got like we have certain, some fire testing things that have been accepted. That's a big one. That's also very helpful. I think one thing that you left out, that I think is like one of we mentioned it earlier, but I'll mention again, is about the alkalinity of the wall, which makes it resistant to mold. So, in our climate, like here where I live, and in much of the Southeast, it is, and well, where you've got a big temperature, delta between the interior and exterior, the ability for the Hempcrete to hold water vapor form without having it condense in the wall and create mold, which is hard to see because the alkalinity of the lime. That is a huge deal in terms of health and longevity, both for the human inhabitants and the building itself. Because lime, one of my early, hurdles was convincing, getting the information, to show the building department that we can lime up against the studs. It's not Portland cement. It's okay. It's not only okay, it's really good because lime is a wood preservative. So, and then I guess aside from that, there is the breathe. That's the opportunity for addressing the breathability component, where you don't use barriers and emphasizing that the wall has to breathe.
Right, and that was one of the key features in the genesis of hempcrete becoming more widely used, especially in Europe. And so there's this modern twist on an ancient technology, and how it came about is you had some of these magnificent older historic buildings that were getting renovation and work done. And then this was, the use of Portland cement, harder, stronger, et cetera, et cetera. And so we'd have that right up next to these old members, and then they were holding moisture and then getting rot. And then now the question was, what can we do instead to where now we don't have that rotting wood when we put the strong material around it? And then that's where the natural limes and the lime instead of Portland came into play. And so that's a strong thing to know, that you gotta, if you're good up against wood or metal, how it performs and how it behaves and how it interacts. And that's very important. Those are good points to make. Any others? And then did y'all incorporate engineers as well?
Oh yeah. Well, everything I've at this point, I don't know if I've ever done a project without having an engineer on board to some extent. The majority of my work has been done, pre any kind of code appendix for Hempcrete.
Right.
So that required, and I feel like I've been pretty fortunate to work with some pretty creative and innovative folks, that have helped us do some really exciting projects. But yeah, I'm right now that may or may not require engineering. We'll just, it's been kind of done. It's been done to the code, but there are some aspects of it. I think that's always for me.
And the
Yeah, I
minimal,
strongly recommend using an engineer, and then just the anecdotal scenario that I have is that we permitted first there in San Antonio. I had zero pushback because they were stamped plans with an engineer, and the engineer knew exactly what the Hempcrete was being asked to do. It wasn't asked to be structural. They knew exactly the lime and the air barriers that we're creating, and then there was, hey, I like what you're doing, and they're happy to come along. And that's one of the things that is very nice in establishing these relationships, professional to professional. It really captures the imagination and the creativity. So I would lean into that, because I know sometimes the creative architectural design community can be at a point of friction, almost adversarial with the engineering community, but there's definitely room to complement one another's efforts on this.
Yeah.
now can we now that the code specifically says that two-story buildings in low seismic zones do not require additional engineering?
If not two-story, Gene, it's limited building height of 25 feet.
25 feet. Okay.
And single story at this point, I believe, with a top plate height. There can play with that a little bit. I won't go to that right now, but the point is, yes, if you use the appendix, if someone takes the appendix, you can use that, and as long as if you follow the prescriptive advice that's in there, you will not need an engineer. Well, you should check with your local. Let me back up here.
Right.
Yeah, that I should do that, to say that categorically. I think that that again, not single out Hempcrete, because I think anytime you're going to take on a project, it's good to talk to your local building department. Go in and say, and usually they'll say, okay, the inspector for that area is so and so. Talk to them directly. If you don't have a relationship with them already, start to work on one, because they can be your best ally. And when it comes to if you to do something that's absolutely doesn't have an engineer, I'd have that conversation with them up front. We're going to be following the code. We're following everything that's within the appendix. Let's talk about that. Do you have any concerns or questions? I would do that up front.
Can you talk about times that you mentioned?
Yeah, because they have a lot of things that they say, Grace.
Yeah, well, I just about, even where in states where the code has not specifically been adopted, the appendices of the IRC are voluntary, and they really have to be adopted jurisdiction by jurisdiction. Minnesota are on the paths to adopt, Austin, Texas. But can you talk about, you recently mentioned that one of your projects in Virginia, before the code was adopted, when you basically showed them the code, even though it hadn't been specifically adopted in the state, they were amenable.
Oh, they were amenable. And that was to Virginia adopting anything. But we had IRC, and when we explained to the county there what we were trying to do and how to go about it, they said, well, why don't you just do a code modification request? And that's just I don't know if that's something that's available in every state, but it was available to us, and that basically just involved some paperwork where this is going to be built to the 2024 IRC, the whole building. It was going to meet 2024 requirements throughout. So that's way, so that really jump started that process, and it was suggestion. So that was because that was part of us doing our homework and going in and having a conversation with them and saying, this is what we're trying to do. The client on the project had a career as a project manager, so he took the lead on that, and he was great. He dealt with all of those issues with them, and I was a part of that, but he was the effort. So there are those kind of avenues can be available.
Yeah, and one thing that we want people to know about is that yeah, those code officials, they have a lot to say grace over, and then they may not be familiar with it. And if you introduce it to them, this is a great way to introduce it, even if that jurisdiction hasn't adopted the complete 2024 with appendix yet. And so that's another thing that is, I guess, a good way to transition into what's next and what's now is that it's adopted into by the IRC. Now, each municipality, sometimes it's state by state, sometimes municipalities will do that and lag. I know Austin is a municipality that did the adoption. I think, I'm not sure if San Antonio has as well. I know that Virginia, the whole state, recently voted. Talk about that process and how design professionals can and should follow through with knowing what's going on in their state, and then maybe are there ways to get involved and play a role of an advocate?
Well, honestly, I think that you guys are probably in a better position to address that than I am. I think that if someone wants to get involved in advocacy or acting as a co-proponent, I think there are different avenues for that through different organizations. That's the code process is pretty. I mean, I've been really impressed by just how I've been sometimes and impressed by how it all and knowledge that it takes to navigate it. So I don't really know that I'm the best person to answer that question, Ray, honestly.
Well, Gene, you want to talk a little bit about the waterfall of these different jurisdictions that are coming in? I know, Tim, your resources are so valuable to not only professionals that are engaging, but code officials that want something to look at and read that they can, carry with them, have in their library. But then, Gene, talk a little bit about the process of what's going on now, and then we can unpack how people will get involved.
Well, each state, and there are 8 states that don't have a state building code. I'm in one of them, Colorado. Also, New Mexico. There are quite a few. There's one that does not acknowledge the IRC, and that's Wisconsin. But the other 49
Really?
do.
Right. Wow.
Yes. No, Wisconsin does not acknowledge the IRC, although I'm sure that they informally do. So every state basically, or every jurisdiction basically has a window every couple years that they have hearings to decide on building codes. Now, yours in North Carolina, we've had, they were supposed to be having these hearings for the IRC last year. However, you had a little hurricane that came through, and basically the building code department, I can't remember what the state department is called, but they basically put everything to talk about hurricane rebuilds and how to, work on the code so that hurricane rebuilds had the barriers removed. So they are going to be in April, and I think October of this year, North Carolina will be taking a look at the 2024 IRC. Now, other states this year are Florida, Oklahoma, I think Connecticut, possibly New Hampshire. So there are, every state kind of has its own thing. Now, here we are in Colorado, and oh yeah, we don't have building code, so we can't just appear before one code body and get this out of the way. But I'll tell you, here in my little county, Larimer County in northern Colorado, we have 5 Hempcrete houses. 5 houses complete. They're not little sheds that were, they have kitchens, bathrooms, bedrooms. They have the whole thing. Sometimes if your local code department is amenable, you can actually, it can catch on regionally, and that it kind of has in Colorado. And I think also, Virginia, they just adopted it, or they just put it on the path to adoption in the middle of January. And part of the reason they did that was because it had already been adopted by Minnesota and Austin, Texas. So I think it is easier for these regulatory bodies to basically give the okay if they know that other regulatory bodies have already done it.
Oh.
And I think that is going to have a snowball effect across the US as these states start to have their every couple year windows where they address code. What do you think?
Yeah, I think you're absolutely right. The other thing, I mean, and basically you're talking about precedent. If there's a precedent, okay, there's the state adopted it, but also just within your state, I think if it hasn't been adopted, being to point to and say, okay, well, this was built. Somebody did. Somebody was willing through lots of hoops to get that built over there. So if you can point to in a state that have been done previously, that's a precedent. That gives them comfort. And so that there are those tools. And as I said, the code modification may be available, requests may be available, as an avenue. I've always felt like the more things that are on the ground, the more built projects that we have and can point to, and that building inspectors can look at, and say, oh, look, that was done there. Oh, and all these things are bricks in the wall, that are, as we build a foundation for this industry.
And you personally have built like 10 of these in North Carolina. So, I mean, I think that North Carolina has a really good chance of just adopting it statewide based on the work that you've done for the past, is it 15 years, 10 years?
Yeah, 15.
When would you say 15? Exactly. So thank you, Tim. You're just a trailblazer. What the hell happened? How did you end up spending 15 years doing this stuff? It's amazing.
Yeah.
Yeah, and you said it well. Projects, the more projects that we get on the ground, the more progress we will make. And then that's one of the motivators of this podcast, is to get design professionals and build professionals all the tools that they need and the support that they need to have successful projects, because good projects equals success. Bad projects, they go the other way as well. And so it's real. It's now. The innovation is available. You don't have to relearn your whole career. This is making its way. It's in code with an appendix. It's making its way into adoption. The industry is maturing. There's a lot here for you. We strongly recommend, as a design professional, knowing what that status of adoption is.
Oh, we're losing you, Ray. Go ahead.
Yeah. Can you hear me back now?
Mm-hmm.
Yeah, I was just encouraging the design professionals, embrace everything and know that it's available. The industry's maturing. You've had the trailblazers like Tim that are there for you. They've got resources like his book. There's advocacy roles. There's design projects to take on. Just know that it's here for you and that it's real and it's something you can take hold of. And then be aware of what's happening in your jurisdiction with that Appendix BL adoption and what the status of that is, and set yourself apart as a design professional who knows this. You don't have to relearn your whole career, but this is an exciting thing to have a good niche that you can take to the market. And as you market yourself and your services, it's something that's nice to bring to the marketplace. Really captures the imagination and the spirit of a client and a customer, as well as you as a design professional. So, Tim, are there any parting advice, bits of advice that you would give to a design professional looking to carve out a niche? There are a ton of different niche applications that a design professional can have. Are there any bits of advice that you would give them in seeking that or establishing one?
Well, I just want to say, I thought your little summation there was really great. But to just tag on to that, yeah, I think it is, if you're, more and more people are approached being asked to do Hempcrete designs. So, if that's something that you feel like you're interested in, but maybe aren't equipped to take on right now, just understand that there are lots of resources out here, and we, at this point in the United States, we have a pretty good bank of experienced people, that would be more than happy to get to lend support, and they can provide you, with information, technical support across a wide range of aspects of this. So don't, be bold, be intelligent, and be open.
That's a good way to put it. Last sum up question is, What are some of the things that you're most excited seeing built with Hempcrete or hemp building materials?
Well, right now, I mean, I'm not. I personally have got a couple of right now that I'm really excited about, and that are consuming much of my time, brain space. So that's in my own little sphere. I think that I'm just so impressed to see all that are being made across the country in on in a variety of styles. I think that's it. There are, again, it's limited by your imagination. The possibilities are vast in terms of architectural expression with this. I think so I'm just excited to see what different people are coming up with, things that I haven't done that others are doing. I love seeing the experimentation, really.
Yeah, and that's a good forward-thinking way to wrap up. We mentioned that Tim is one of the OG original gangsters in this arena. And then when we were preparing for this podcast, we were like, man, we could do about 10 different episodes. And so one thing to do if you're catching this podcast and there's burning questions that you have, reach out and connect with us on the Hemp Build community. And then let us know what questions you have and what podcast you would like to see next. What are those burning questions? There's a lot of testing and data that's coming into the market from domestic producers and professionals, as well as other manufactured goods that are coming in, to where you've got that data to put into all of your spreadsheets and how to do that. Let us know what you want to focus on to where you can have successful projects, and then we'll see you on the next podcast. Thanks for joining us.
Thanks a lot, everybody. Bye now.
Take care.